Hey, Chemsters, this is Mrs. Vandalay bringing you the Chapter 6 E1, E2, SN1, SN2 practice. This is your last practice for this chapter. So for each problem, we're supposed to write out your products, label each as, the following, then answer any of the questions, okay? Hopefully by now this is coming a little bit easier for you. You are more able to identify which of the four types of reactions it's going to be, and from there identify your product. So let's see how we did. Okay, so here we have our setup here. The huge clue is we have heat, so automatically I knew it was an elimination type. This is a primary, therefore I knew it was an E2. So let's see here, I scrolled it down because it's primary and heat. So I knew I was going to make a double bond between the first and the second carbon over here. The hydrogen left and joined the nucleophile, and then here's my leaving group, okay? The next one, scroll down. Once again, I see the word heat, so I'm thinking it's an elimination. I notice that this is a tertiary, which is usually going to be E1. It could be E2 if I have a very strong nucleophile like sodium hydroxide or potassium hydroxide, which I don't. Therefore, it's going to be E1. I wrote why, because it's a tertiary. Heat and the weak base, remember tertiary and strong base is going to be E2. So I have my substrate, my nucleophile, my organic product is a double bond. So notice that each of these groups are totally identical. So I'm only going to have one alkene in this product. So it made no difference which was my beta hydrogen there. And so here is my here is my nucleophile with my H plus attached. Remember, it's dehydrohalogenation. So the hydrogen had to leave and join the nucleophile. Just like before, if this is a neutral nucleophile, this is now going to be a positive nucleophile. And then there's my leaving group. Okay, let's try the next one. All right, so this is a little bit more difficult. We have heat. So I know it's elimination, but this carbon is actually a secondary carbon. So it is not a dead giveaway if it's primary or tertiary, like that would be. So it's a secondary. So now I really have to look at this. This is a weak nucleophile. It is going to be E2, or sorry, E1, because it is a weak nucleophile. Sorry about that. But notice what happened, because here's the carbon where the bromine is. This carbon is different than this carbon. It's not identical, is it? So I could use a beta hydrogen from the first carbon, or I could use a beta hydrogen from the second carbon. So I end up with two products, okay? And is one of them more predominant than the other one? Yes, it's the green one, the second one right here. But it's not to say you're not going to make any of this. You're just going to make more of this one. It's a little more stable. So there are my two organic products. Here's again my nucleophile is neutral here, so it's going to be positive when the dehydrohalogenation occurs. And here is my leaving group. Okay. So it says, will R and S be needed? Answer is no, because you don't worry about R and S with E1 or E2. Although the reactant is R, if you check it out, the product doesn't have three different groups off the C2. Or if I look at it, it only has two different carbons, two different groups off of here. There is no hydrogen, so there is no need for R and S. Okay, let's go on the next page. So if you look at this, the setup is almost identical. What's the only difference? It's my nucleophile. Now this is a strong nucleophile, all right? It's a negative. So I made it an E2. But my products are identical. The only difference is that this is neutral. It doesn't have an extra H because the H joined here. But again, I have the exact same setups, okay? And again, will R or S be needed? The answer is nope, not with elimination, you don't. All right, so let's look at number 5. All right, so there is no heat, so I do know it is a substitution. So now let's look over here. Here's my carbon. It's a secondary of a carbon here and a carbon there, but that's a hydrogen. So now I have to look at here. It's negative, therefore it must be SN2. Why is that important? all right, because will your product be cis or trans or both? Now, if it were SN1, your answer would be both, okay? But because it's SN2, we start off with trans, so my product had to be cis, all right? So I wrote you only get the opposite with SN2. You do not get both, okay? So let's look at number 6 real quick. Okay, so is my substrate primary, secondary, tertiary? It is secondary. All right, here is my carbon. I have a carbon, a hydrogen, a bromine, and another carbon. So I only have 2 carbons off of this one. Is it going to be E1, E2, SN1, or SN2? Well, there's no heat, so no substitution. And this is a neutral nucleophile, so it's going to be SN1. The question is, are RNS needed? I go, yes. Why? Because it's secondary and it's not symmetrical. So the question is, am I going to get R or S or both? Well, the answer in this case is both, okay? So I drew it out so you can see. So my original product I have is S, okay? It's going in the counterclockwise motion. So here is, I left off the H's, but here is my weak nucleophile. Notice my organic product both has a positive on it, but here is my nucleophile attachment, and here is my nucleophile attachment. So I have one in the S and one in the R. So I have 2 organic products, and then I have a bromine is my leaving group. So again, why do I have 2 products? Think about what happens. My first step in SN1 is that the bromine leaves. Then there are 3 remaining bonds form that trigonal planar with a carbocation. So my nucleophile can attack either from here, the front side, from where the bromine left, or from the opposite side because it is trigonal planar. It's a 50-50 mix, okay? Well, I hope this helped. I hope you're finally getting this figured out. If you have any questions, please let me know. And until then, don't wait to be great. We'll see you next time. Bye-bye.